Good morning. Come on in and have a seat. We've had a wonderful symposium so far, and I expect us to have more. One of the speakers for this morning, Robert Michael Smith, I've known him for a long time, and his introducer is Patrick Veerkamp, who I've known far longer. Patrick is well known in this university as a caring, giving human being, but he's also well known as one of the best ceramic artists around. Would you please welcome Patrick Veerkamp?
Well, good morning. I was talking to Robert just prior to this and kind of cautioning him about this impending frozen precipitation that we're going to be having. He assured me that our predicted half an inch, it won't bother him much at all after what he's been experiencing in the Northeast and in New York City this winter. So that's good. So when I was asked to do this, give this presentation, this introduction, Mary said, well, you know, Robert, kind of a modest guy, and he doesn't really necessarily need an elaborate introduction. So I thought, well, okay, I'll try to cut back as much as I can without slighting his professional prowess. And so I titled my introduction, Too Numerous to List, and that will be a common theme throughout this introduction. So Robert Michael Smith is a sculptor, 3D digital artist, web designer, and associate professor of sculpture, 3D computer visualization animation, desktop publishing, web design, philosophy of aesthetics in the Fine Arts Department at New York Institute of Technology. He previously taught at the Pratt Institute, School of Visual Arts, New School for Social Research, Parsons School of Art and Design, University of the Arts, the Sculpture Center, University of North Dakota, University of Hawaii, and San Jose State University. In addition, he has served as guest artist at many colleges and universities throughout the United States and abroad, including University of Minnesota in Minneapolis, St. Paul, University of Washington at Seattle, Washington University in St. Louis, University of Alabama at Birmingham, Lacoste School for the Arts in Lacoste, France, Honolulu Academy of the Arts, and others too numerous to list. In addition to his work in academia, he was on the board of directors for the New York chapter of SIGGRAPH, an international community of researchers, artists, developers, filmmakers, scientists, and business professionals who share an interest in computer graphics and interactive techniques. He was the past president of the New York City Sculptors Guild. He was the original web director for the International Sculpture Center. I took some notes here this morning after talking to Robert. He's a board member of the Digital Stone Project, and various other enterprises, again, too numerous to list. Smith has lectured on his sculpture and digital work at several major international conferences worldwide, including the International Society of Electronic Arts in Montreal, numerous presentations at the Biennial International Sculpture Conference, Intersculpt, where he made a presentation to the French Senate, and the prestigious Brown Symposium in Georgetown, Texas. I just added that this morning. And other venues too numerous to list. He has written he has written articles and had his work published in several books and journals, including a recent publication titled Art in the Digital Age, Art News, Computer Arts, Sculpture Magazine, Maquette Magazine, and Leonardo, a publication of MIT Press. He worked as a 3D computer modeler, script developer, and art historian on a creative team for the interactive CD-ROM game Millennium Auction, which I just looked up this morning on the web, contributing significantly to the critical acclaim and award-winning status achieved by this pioneering multimedia production. Smith's sculpture and digital art have been exhibited extensively worldwide, including a digital stone exhibition in Beijing, Beijing Today Art Museum, which traveled throughout China to many at Shanghai Museum and various other museums as well. Insight, outdoor sculpture exhibition at Governor's Island in New York, Art Cologne in Germany, Alien Beauty and Universal Form, a solo exhibition at the Foresight Art Center in Amman, Jordan. And in this instance, I can tell you for sure that this list is much too numerous to list. His sculpture titled Paradise Bird Burlesque is in the permanent collection of the China National Museum of Fine Arts in Beijing. Robert earned his Bachelor of Arts and Master of Arts degrees from San Jose State University and his Master of Fine Arts degree from the University of Hawaii. Parenthetically, if you want to get an idea of how Robert makes some of his work, you can go online. When I Googled him, of course, I came across a really interesting video on YouTube, and I would recommend it to you. Just take a look. It's pretty impressive. So before I turn over the microphone to Robert, I want to share with you a brief statement written by him about his work. He says, "Art is alchemy. Alchemy is the magic, observation, process, and ritual of life. My sculptures, both virtual and actual, are conversations regarding the archetypal forms that are the basic structures of nature. I build alien abstract worlds that become familiar through frequent immersion. These worlds are constructed to open exploration to the deepest regions of the human psyche for development within the landscape of the imagination." And I don't know about you, but it kind of sounds like poetry to me. So it's my pleasure to introduce you to sculptor, printmaker, designer, entrepreneur, administrator, philosopher, poet, college professor, and I'm speculating all around terrific guy, and alchemist, Mr. Robert Michael Smith.
Thank you. Very good.
All right.
Excellent. Good morning. Everybody can hear me fine? Do you hear me fine if I'm walking around? Okay, good. Yeah, well, it's nice to have that full explanation. Saves me some time because I'm, in 1 hour, going to try to compress an awful lot of data, and especially a lot of visual data. But I wanted to thank Mary Visser for putting this presentation together and inviting me. And there's a number of old friends in the audience. I want to thank you for being here. We've all been sharing this path together for quite a long time. For me, it started at San Jose State in '76 when I had the good fortune to attend a small dormitory get-together with, at the time, barely known Stephen Jobs to convince the business majors into going into this new, interesting field. And by the time the whole thing was done, I said, well, this is all very cool, but I don't see myself running a company. I don't see myself writing software. And he goes, well, what do you want to do? And I said, well, I just started making sculptures. I've been a printmaker, an animator. And he was like, oh, this is the real future. And he made a prediction there, and he said, this is something you're going to be able to do at home yourself in 15 to 20 years. Because I was 23 at the time, and it's like, that's saying it's never going to happen. But I did listen, and I stayed a personal exploration, which was part of the title of this presentation, which is In Search of the Lost Coord. And for those of you of a particular generation, this play on words may have some significance. Of course, for those of us involved in doing 3D modeling animation, it's all about coordinates, it's all about points in space. But by extension, so is the universe, so is our existence, and so it seemed to me an appropriate title. I'm going to be showing a number of images and some videos, and hoping can we switch to the, okay, very good. Let's see if I can start a video first. This is a very short video, and which also includes Bruce Beasley, who you all saw present yesterday. This is a 3-minute trailer for a much longer video. But it also introduces Carl Bass, the CEO of Autodesk.
On the technology front, we've never had more ability to use computers to advance the idea of design, to give people more tools to understand what they're doing, to visualize the things, to simulate, to analyze. It's all part of a direction to, give people better tools to experience the things they're going to build before they actually build them.
The ability with a computer to try things, move things, change them, duplicate the shapes, move them around without worrying about gravity, without worrying about gluing them, without worrying about cutting shapes, was really a revelation. It's freedom.
Then once I've found the shape and the forms that I'm looking for, and I have the beauty and the intensity and the brilliance that I'm looking for in the work, then I'm able to send that file out to the rapid prototype printer, and then within another couple of days or so, I have a beautiful finished physical model.
It's a challenge, and it's an exciting challenge. It certainly couldn't have been possible when I started thinking about these things 40 years ago. I wouldn't have imagined that you could make a representation of something so complex as this.
I started working in stone because the material brought forward a permanency that I couldn't find in other materials I was working with.
And I think the definition on the line on this one is working a lot better. It's just bringing the hand back in.
For me, the sculpture is like making poetry with shape.
This is a video that you can access online. It's posted at YouTube. I also wanted to just briefly introduce you to a couple of other websites, because there is so much data to cover, I can't get through it all in an hour lecture. So I'm just going to direct you to a couple of resources. I really started making sculptures in '76 after having an extensive background as a printmaker and photographer, graphic designer. And there is an archive here that starts in '78, which really covers my thesis exhibition at San Jose State. It goes through my years in Hawaii. I'm going to skip over this history. Again, you can Google my name and you'll find this link. Also, if you're interested in more information on the Digital Stone exhibition, which was sponsored by Autodesk in China in 2008 to 2009, you can go to digitalstone.net. And then for a couple of years, ran a gallery in Beijing, and there's a lot more data about all of the artists that were involved in all of our work. But I'm going to focus now on trying to get through the things that are, what the hell's going on? Okay. So again, since I was a printmaker, but I was making sculpture for a number of years, I was a foundry rat, and working in bronze and going through the whole foundry process really robbed me of all the other media that I had been working in. When I came to the computer in the late 80s, early 90s, I was able to access my previous skill sets as a printmaker. Now this piece here goes back to the late 90s, where I was doing prints on canvas, but the images themselves were being designed in 3D programs. So the same program that I was using to make sculptures, I was also making digital prints and animations. And this piece here got a lot of attention in Leonardo magazine and several international exhibitions. And it has a lot of reference to what I'm going to be talking about towards the end of my lecture, which is biological sculpture. So I have a history of sort of developing these sort of alien creatures, which are getting closer and closer to being actual rather than just virtual. I was fortunate enough through my job at New York Institute of Technology to get access to 3D printers many, many years before it became the hip thing that it has become today. I started working with Z-Core in the beginning, and these are a couple of very early pieces. This sculpture here was actually in the first International RP exhibition that Mary, I think it's in the permanent collection. I saw it on the dinner table last night. And also, if you pay attention to the titles, I wouldn't exactly say I'm a poet, but I certainly like to play with language. And the sculptures themselves sort of kick off that play with language. I think it'll also become very clear when you pay attention to some of the titles that there's an awful lot of Freud and Jung in my work, probably a lot more than the sort of obvious golden ratio, Fibonacci sequences that the work, there is an algorithm of life, but I'm rejecting the pure math art, and I use math as a starter, and then I play and add a lot more archetypal symbology into the work. Now, I've included this piece because, again, it has more reference to where my work is going. You'll see that there are prints in the background that are a storyboard of a short animation where this creature comes out and does this dance. Now, just a week ago, I'm constantly researching what's going on in science. There's a group making nanobots that are supposed to be injected into the body to clean. Now, I've been hearing about this for a long time, but I actually saw some photos of it and surprised the hell out of me that it looks exactly like this. But that's happened to me a lot over time. Again, my background as a metal person, I haven't completely given up on, although digital technologies have allowed me to expand my vocabulary in processes and materials. And I'm going to be spending a lot of time talking about stonework soon, but I did want to include some stainless steel pieces that I did in Beijing just a few years ago. And these last two pieces are in the permanent collection of the Contemporary Sculpture Museum in Datong, China. And this one I've held on to dearly, and it's in my studio in New York. Now, this model of how I present my work, which is usually a combination of pieces on pedestals, digital prints on the wall, as well as rapid prototype sculptures on shelves, was really developed pretty early on, and this was from a showroom that I had in Brooklyn back in the about 12 years ago. But I had spent a lot of time living in Italy and spent a lot of time around stone, and I loved the quality of stone, but after being a foundry rat and burning myself and cutting myself and breathing all kinds of obnoxious fumes and dusts, it didn't feel like I wanted to necessarily get into that habit with one more process. So even though I had some experience carving stone by hand, I really came to it more because the digital files that I was creating lent themselves to go to CNC machines. And this was one of the first pieces that I did that was cut on a CNC machine about 12 to 15 years ago. I'm losing track of time. The same file then was used to cut this in foam with a polyurethane skin. This is sitting out in front of the public library in White Plains, New York. This is another foam cut polyurethane piece. It's been exhibited in a number of places. Here it's sitting on Governor's Island in New York Harbor. Gynophlorosiraptor was one of the first pieces that I had carved in China. Instead of working with machines, I was able to take my rapid prototype models to China, and Bruce Beasley introduced me to Dingli, which is just north of Xiamen, China. This is a black granite sculpture on about this scale, and it's been sitting in the window of the library of our university at the corner of 61st and Broadway in Manhattan for the last several years. This piece is also in the window, a white granite piece that was also carved in Xiamen. Red granite, also in China. And of course, Bruce introduced me to Carl Bass back in, I guess it was 2007, and we had this very nice conversation, which you see in the video. And we got this wonderful project that Autodesk sponsored us to produce a number of large-scale granite pieces, again, using traditional craftsmen, but work that was all designed in computer, and all the models were 3D printed. So I loved, it was really nice to see these pictures in the traditional environments that they were in, both indoor and outdoor. Again, if you go to digital-stone.net, you can see all of our works. There was 20 sculptures, 5 by each of the 4 artists involved. I'm going quickly through these things. Again, you can go online to see the work, but I want to get to sort of the meat of the biological sculpture, which I'm sure a number of people are here to hear about. But before I do, I've been working with the Digital Stone Project for a number of years. We sold off the business itself. It's now owned by Jeff Koons. But we're in a much better situation where we don't have the millstone of a company around our neck. We are actually doing really not-for-profit residencies, which is what we want to do. And we're working with a group called Garfagnana Innovazione in the Tuscany region of Italy. And this was from the 2013 summer workshop. This piece was carved by a 7-axis robot. This is where the stone comes from. Maybe you've seen images of the quarries above Carrara, but it's one of the real beauty spots on the planet. This is the small town of Gramolazzo, probably not more than 200 people. It's a community that lost its industry, which was the stone trade, because it's all, just like farms, the small groups got sucked in by the larger groups. So this small school that has this robot is the thing that's keeping the life of this little hill town alive now. This is one of the robots, and this one actually has a 3D scanner built in. So this can actually simultaneously scan an object and carve it. And with 7 axes, it's able to get up and around and under. Of course, they don't look so pristine once they're actually in use. And of course, this is the piece that I designed for last summer, the 2014 Digital Stone Workshop. And these are images from the Rhino files, renders. This is the MakerBot setup. So again, I start with a small model that I can work from. This is the RP. There's another example of this piece that's in the exhibition here. And this is the piece being roughed out in stone. You see that it carves in contours. There's a lot of artists that like to leave the marks in there. I generally tend to remove them to get back to my original idea, but there are times if I see something that seems richer than my own idea, I'm quite open to leave it in. So you can see the roughed out stone with the small MakerBot print in front that I'm constantly using as reference. And you can see that the robot removes an awful lot of materials, but in order to get in and really put the refined lines in, I have to still do this by hand. So I actually do need to be a stone carver. This is the Museum of I forget exactly what MUSA stands for. I think it's something like Science and Art in Pietrasanta, Italy, where we had our exhibition last summer. And this is the finished stone piece, and it's, as you could see in the reference to myself, it's a rather large stone piece. So now I'm going to move into the part of my presentation about the biosculpture. Yesterday you saw a presentation by Dr. Anthony Atala. I first was introduced to Dr. Atala through a TED.com lecture about 3 years ago. Now, as soon as most people see his lecture and clue into exactly what his medical technology research is going to lead to, one would think that simply extending life and saving human beings should be plenty. But when I saw the video, what I saw was the technology to realize an idea I'd had 20 years earlier when I worked on this CD-ROM game. And I had a sculptor of the future who was making human meat sculptures. Now, this was supposed to be a bit of a satire when it was written back then. But there were a lot of sculptors that I had written in that were using advanced technologies. And in the course of 20 years, I had become just about every one of them, except the sculptor who was making human meat sculptures. When I suddenly realized that this was a possibility, I also realized that there was another responsibility, that the satire of just making a human meat sculpture is it's about the shock, it's about the fright. And there is a certain part of the art world that's about shock and awe. But there's another more important part about art, as far as I'm concerned, which is about transcendence. It's about lifting the human spirit, and it's about being at the forefront of human consciousness. I came to this from spending a lot of time studying the philosophy of aesthetics. So I realized that I had a responsibility to actually have a real, solid, scientific reason for doing this, as well as my own art reasons. So the more I thought about the fact that I could do this thing, and I did make a phone call to Dr. Atala, and he did accept my proposal, and I will be showing some clips from a longer video where we talk a bit about this project. But what I came to the table was that as someone who'd been working in 3D visualization for 20 years, I understood the importance of it as a design tool, as a prototyping tool, and then as a means to manufacture. But it's also used a lot for dynamics, recreating life. Like if you're putting together a bridge or a building, will it stand? You know, gravity, mass, and structure can be programmed into these programs. But the data that you put in is only as good as the data that you have to give it. So if there's unexpected data, your simulations are going to be worthless. You still have to have physical models. You still have to have physical simulators. Now, if you've been following the news for the last few years, the world of science, at least when it comes to the space agency, they're tracking to land on Mars. They want to put a human being on Mars by 2032. It's a suicide mission. It's a one-way trip. And even if they do send somebody there and bring them back, it's someone who will have experienced several hundred years of radiation in a matter of a couple of years. So, I mean, that's like living in Arizona for umpteen years. So my thought was, why would we do this? Why would we send somebody to be radiated? Why would we send an animal up to be radiated? Why would we send any living thing up to be radiated? So I came up with the proposal to print a part that could be wired with bio sensors, hooked into the intelligence system within a space capsule system, also that could piggyback on Mars rovers, and could be tracking not just a single individual, but if these things are made very, very small, entire colonies and control colonies in bioreactors at a fraction of the cost of sending even a rat. And we would be getting data that's more specific to human genes. And that data then could be used, once it got back to Earth, to actually change the DNA of the cell structures using transgenesis. There are creatures on Earth that can withstand 1,000 times more radiation than human beings. And there's been lots of work in transgenesis of identifying what those genes are and integrating them in. So there was this larger idea that this would be a process of evolving a human gene that would be better at withstanding radiation, that would be better at not being impacted negatively by zero gravity over extended periods of time, would not be as negatively impacted by harsh environments, because once we go to Mars, we're not stopping there. They're already talking about sending submarines to Europa, if you follow this. That there is this drive to put the human being out into space, and it isn't going to be Captain Kirk chasing green women around space. We've been evolved to do as well as we can on our planet, but we had to use our intelligence to create technologies to actually expand our ability to even to survive on our own planet. We are not really built for the trip elsewhere, but we certainly have an intention, we have a conscience which is driving us for space exploration. So we have to face this fact that if we have a design problem, the weak link in this whole system is the human body. So as a designer, it was like, okay, so we start from scratch, but we start down at the genetic level, and then we build up from that. When we finally do start sending people into extended space, there's going to be the opportunity to make changes in that design and keep improving that design. So this was the proposal that I gave to Dr. Atala, which shows a translucent exoskeleton. The living tissue is the small red part with the kind of little nipple on the end of it. The limitation, of course, was the research biological lab material, or the living cells. It couldn't really be much more complex than an organ or some other rather typical human anatomical feature. So, and again, this is a very, what I consider an early design. This is stage one of a much longer project that has at least 10 stages to it that I'm calculating over the next 10 years. Now, in the video that I'll show, you will see me holding up a little vial that actually has the printed living sculpture in it. Now, it was in a nutrient jar, and I was told there was only enough nutrient in it to keep it alive for a couple of weeks. In fact, it seemed like it was alive, or there were still living cells in it for several weeks, but it was never meant to live. And again, life is not sentience, life just simply in biological terms. But after I had this dead sculpture, it seemed like I needed to take it to the next step, and I had spent that summer traveling along some pilgrim routes through France and Spain, visiting cathedrals, and it seemed that a reliquary was the appropriate next step. This is an installation at a small gallery in Northern California from 2 years ago. And there's a video clip in the background you'll see. And you'll see Dr. Atala's face there, because this is from the clip video clip that I'll be showing. But the reliquary is the black shroud on the wall. And in the little orange vial is the small biologically printed sculpture, and the translucent exoskeleton is next to the jar. And a lot of what I'm talking about, I know probably sounds crazy to some people. It sounds science fiction, but it's actually based on an awful lot of research that's really being done in the world today. And I do have a list of suggested reading for anybody who does want to pursue this. A lot of this is based on going down to the level of string theory, understanding the structure of the universe at the smallest scale. One of the more significant books I would point out is Regenesis, How Synthetic Biology Will Reinvent Nature and Ourselves by George Church. Actually, it should be Dr. George Church, who's at Harvard, that is really one of the people at the forefront of genetic engineering. And also a very, very interesting book that builds up on Ray Kurzweil's projections from Age of the Spiritual Machines and the Singularity is Near, is one by Michio Kaku, who's a physicist from New York University, called Physics of the Future, How Science Will Shape Human Destiny and Our Daily Lives by the Year 2100. I actually require this reading of my students, along with things like the Dancing Wooly Masters and anything that really links up art and science and technology. But I do want to play some of the clips off of the biological. It's a half-hour video, so there's not enough time to play the whole thing. I'm just going to take selected clips as we go through it. Where is the... Does anyone know which drive the... Oh, here it is. And I've been working on a biosculpture project. Can you turn the sound up? An idea that I had over 20 years ago. And when I was watching TED.com last spring, I saw the work that Dr. Anthony Atala was doing at Wake Forest Institute for Regenerative Medicine in Winston-Salem, North Carolina. I had my assistant get on the phone to Dr. Atala's assistant, and it was a nice surprise to have him accept a phone call. And that began this art science collaborative project we've been working on all summer, and we have just finished stage 1. I would like to introduce you to Dr. Anthony Atala.
Thanks for being here today.
And thanks for having us, and really thanks for making this sort of strange dream become possible. I've seen the TED.com lectures, and there's always the short bio. I'll be jumping. But it really wasn't very full in, like...
These type of things are worthwhile projects to pursue.
Have you been approached in the past by an artist to do an art-science collaboration?
We actually have had art-science collaborations in the area of photography, for example, but not really in the area of sculptures. So this was the very first time that had come up.
In the TED.com presentation, you introduced a young fellow from college in Connecticut who was, as I understand, someone who received a bladder when he was much younger. So now he's living a much more normal, productive life. I understand that it wasn't the rapid prototype technology that did that, but it seems to me like it's
the consistency of a gummy bear, and with the cells within it, and then what happens is the cells take over and they start growing while the gummy bear gel actually goes away, and then you're left just with the cells that have made the new tissue. So basically the construct gets printed one layer at a time with the gel and the cells. And then the gel gives the structure the three-dimensional form that it needs. And once we place these structures into the patient, these gel materials dissolve away on their own, leaving just the new cells that are making the new tissue. So the cells from the new tissue, and once that happens, the gel goes away.
It seems to me that something like implanting an ear would be a much easier sort of human test to accomplish even before you are putting something internal.
Well, so the whole concept is you create these three-dimensional structures with the cells, and you put them in the body, and then the body will give it the rest of the life it needs. Blood vessels into it, the nerve really had any ethical issues with doing that, because in reality they're the patient's own cells, and also you're avoiding rejection because you are using the patient's own tissue. So from our perspective, we are taking the tissue from the patient and putting it right back into the patient, and therefore the patient has full knowledge of what's going on, and of course that's what they want to have done.
Sort of joked a little bit, we sort of expect the peasants to come out with the pitchforks. There clearly is this kind of linkage to film, and cells and plant cells could be combined in ways to create new types of materials. I mean, the industrial possibilities of new materials is fairly unlimited here. Outside of science fiction, I haven't encountered anybody trying to do exactly what I'm trying to do, at least yet.
Yeah, no, we have never encountered anything even close to what's being done here now. For us, I think it was also the element of where science reaches out to the public at large, and art is often a good way to do that.
When I first had this idea, as any artist would want to do a self-portrait, these creatures that I have in mind to build, and I've been designing these things in animation for over 20 years. The design work has really been done to a large degree. For me, it's going to be even more real when it's my DNA. I'm very, very pleased you were able to use research.
I think those are important questions. I'm looking forward to seeing what you come up with.
I was curious if you had any questions for me.
Obviously, you came up with this concept over 20 years ago.
Education.
Talk about
I
myself.
do have to say that printing a sculpture with human cells was really something that I thought the only way I was going to be able to do that is if Kurzweil was right and I was able to extend my life into maybe another millennium. So the fact that we've accomplished stage one of that is like having your dreams come true, and I really greatly appreciate that.
Well, that's great. Well, it's been a pleasure working with you, and I'm looking forward to see what else lies ahead.
Now, anybody who's interested to see the full half-hour video, again, it's available at YouTube. If you Google my name and Dr. Anthony Atala's name, or if you can remember the title Bioform Atala Smith, you can find this and you can watch this at home. I know that we're getting close to time. Do we have time for questions? Okay.
Yep, we do.
Are there any questions?
Yes. Any questions from the audience? We have about a few minutes for this.
Looking forward, Robert, what do you see as what is the next iteration of your biological sculpture? Do you see doing more of the same or moving into new territory?
Well, it's an ongoing research. The good news is that what looked like was going to be an astronomically expensive project seems like technology, even just in the last 2 years, there are suddenly people who are using maker bots to print cartilage and bone cells. There are people in Silicon Valley setting up bio companies in their kitchens. So there are people making, and the most expensive thing was going to be the bioreactor, and now they're printing bioreactors inexpensively on MakerBots. The reality is that the bell curve is exponential at this point. Part of this significant thing for me is, yeah, I want to piggyback some of these things on Mars. I want to have the first biological sculptures on Mars. But the real advantage of this is actually should be of interest to anybody who worries about the rights of animals and human beings not to be guinea pigs. There's lots of pharmaceutical companies that are killing rats, humanized mice, in fact, but by the thousands, by tens of thousands. There's rabbits, all kinds of creatures in space. We've lost bears, we've lost dogs and fish and monkeys. It doesn't make sense. It does make sense that we need to research. It does make sense that we need to have physical simulators, but it doesn't make sense that we are killing or maiming sentient beings. So this technology I see as being physical simulators for a wide range of needs for, it's not just the pharmaceuticals, it's also the makeup industry. You know how many creatures are maimed simply to test makeup, lipstick, eyeliner? It's pretty horrific. So I see these as being significant in that regard. But I also see it significant in that with the use of transgenesis, we can actually create new materials at the cellular level. Yes?
Time for 2 more questions. Yes. Okay, so your sculpture and everything was super cool, but it only lasted for so long. You know, it could only live for a certain amount of time in the media. So do you foresee yourself, whether individually or in partnership with other scientists, creating something that could live on indefinitely? Like whether part of your sculpture is the media, or whether maybe it is some sort of maybe photosynthetic thing that can create its own sort of nutrients? Basically my question is, do you see yourself creating something that could sustain itself or be sustained for longer or indefinite periods of time?
Yeah, that's a good question. Let's make it really clear. I don't invent or create anything. I do lots and lots of research. I research the research, and I figure out how to take seemingly disconnected research and put it together in new ways that can make sense as a path to go forward. The doctors are already doing this stuff. The scientists are already doing this stuff. They're already moving forward. I'm just trying to engage the conversation to say, you got a design problem. Let's pay attention to the design problem before it becomes a bigger problem. Or maybe we have some solutions here that we need to move forward with. Now, somebody asked yesterday whether anybody's doing anything with the brain. Dr. Atala did indicate that there's brain research going on, especially with 3D printing. But if you do enough research, you realize that last summer somebody printed a miniature human brain, 3D printed a miniature human brain. They're 3D printing everything. We are at a cusp in our culture, in our society, that science is taking us someplace that most of the people in this world are not prepared for yet. I'm sort of hoping that more my role as an artist, I'm a content developer, not an inventor. But I want to create content that humanizes this technology, that puts it in the conversation of making sense for what the needs of people happen to be. So the answer to your question is yes, it's going to happen. Whether it's me or somebody else, it's already tracking. It's happening as we speak all around the world. Lots of money is being spent on this.
The potential for ethical questions concerning the possibilities of having bio sculptures.
For me, it's all about ethics. And this is where I think that the artist is probably most important. I've always liked Joseph Boy's idea of artist as shaman. Shaman being the conscience of the world. If we don't pay attention that there's a social design problem, who is going to do it? So the ethics is, they're going to do this thing, and they may be doing it for economic reasons, which may not necessarily be the best in the long run. We've seen what corporations have done. We've seen what governments have done. We have to take control over more of this. So I'm wanting to engage in the conversation to bring ethics in from the beginning, which is why I'm very clear that I'm not engaged in doing research on the brain, and don't want to be, because I don't want to be involved in creating sentience. That's going to happen, though. Artificial intelligence or deconstructing or reverse engineering the brain, it's in the process of development right now. But we can engage ourselves in the ethics of this. I was approached by one group that surprised me on the ethics. They were worried about me sending biological material to Mars. And it's like, well, I'm not the guy who's sending stuff to Mars. I'm hitchhiking to Mars, right? We're already sending stuff up there. And what happens when the first astronauts die on other planets? So, I mean, there's levels of ethics here that even I hadn't considered until I started presenting this work and people started bringing it to me. I think that at this point, what I'm doing sounds scary, but it's really just extending what people have already been doing and what other artists in film, probably one of the best films in this regard, I think, is Blade Runner. And since that film came out, I've been tracking that. I mean, I see myself as Decker. I can't begin to tell you how many times I've sat in foreign places eating noodles while there's a mix of tradition and future around me. This is why I'm not here to necessarily just show what I'm doing. I want to be here as kind of an early role model to say, you know what, 20 years ago, a group of us started doing 3D printing and stuff before everybody else. We won. Everybody's doing it now. Now's the next step, and it's biology, and it's the involvement of all the artists that's going to bring in ethical control, or at least some ethical direction.
One last question?
When you made your own biological specimen, exactly what type of cells of yourself did you use? In other words, what is a blood cell, a skin cell?
All right, and to be really clear, my intention is to use my own cells. At the present time, and in stage 1, I could not use my own cells. And there's legal reasons that most of you, again, I'm finding out stuff that I wouldn't have found out if I hadn't gone through this process. None of us in this room have got legal rights to our own DNA to go do experimentation. You have to get scientific and legal clearance. And it's a process that takes 3 to 4 years if you are slotted with the right people. You know, so I have to have scientists on board to even help me do this thing. So the material that was used, you know, there's lots of language that scientists use because they don't want to deal with the ethical and legal questions. So they're very opaque about use of language. So whenever Dr. Atala talks about this, he will only refer to it as research lab material. It is living human cells, and they will go so far as to say that, but they don't want to put it in the context of being tissue. They don't want to put it in the context of it being anybody's DNA. It's very generic. In fact, from what I understand in the conversations we've had, is it could be a combination of individuals at this point. It's just, it's my own idiosyncratic ego as an artist to want to use my own DNA.
Thank you, Rob.
Thank you.